Writing the joint probability mass function of variables. Understanding the concept of joint probability mass functions, PMFs, is crucial for analyzing and modeling the behavior of discrete random variables. This article provides a comprehensive guide on writing the joint probability mass function of variables, along with practical examples. Understanding joint probability mass functions. A. Probability mass function. A probability mass function is a function that gives the probability that a discrete random variable is equal to a specific value. For a random variable, x, the PMF is defined as p x equals p x, where p x is the probability that x takes the value x. B. Joint probability mass function. When dealing with two or more discrete random variables, the concept of the joint probability mass function comes into play. The joint PMF, denoted as p x equals x, y equals y, describes the probability that two random variables, x and y, take on specific values simultaneously. The joint PMF is defined as p x equals x, y equals y, equals p x, y. This function is essential for understanding the relationship between the variables and is foundational in various applications, including communication systems, network design, and statistical modeling. How to write the joint probability mass function. Step 1. Identify the random variables. The first step in writing the joint PMF is to identify the discrete random variables involved. For example, let's consider two random variables, x and y, that represent the outcomes of rolling two dice. Step 2. Determine the sample space. Next, you need to define the sample space for the random variables. For two dice, the sample space consists of all possible pairs, x, y, where x and y can take values from 1 to 6. The total number of outcomes is 6 times 6 is equal to 36. Step 3. Calculate probabilities. Now, calculate the probabilities for each pair, x, y. For instance, the probability of rolling a pair, 1, 1, is as follows. You can create a table to represent the joint PMF for all possible outcomes as shown below. Step 4. Normalize the joint PMF. Ensure that the total probability sums to 1. In this case it shall be as shown below. In our case, since there are 36 outcomes, the sum will equal 1. Python programming example. To illustrate how to compute the joint PMF using Python, consider the following code snippet. This code creates a data frame representing the joint PMF of rolling two dice, where each cell contains the probability of each outcome. Question: what is the probability of rolling a sum of 7 with two dice? Answer: to find the probability of rolling a sum of 7, we identify the pairs that yield this sum, 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. There are 6 favorable outcomes, so the probability is as shown below. In conclusion, by following the steps outlined in this study guide, you can effectively compute and represent joint PMFs for various applications. For further reading, consider exploring scholarly articles on joint distributions and their applications in engineering contexts, such as IEEE Xplore and Springer Link.